people are dying. Entire ecosystems are collapsing. We are in the beginning of a mass extinction, and all you can talk about is money and fairy tales of eternal economic growth. How dare you?
This is the story of how an eccentric environmental scare grew into a powerful global industry.
It's a wonderful business opportunity, okay? You want climate, we'll give you climate.
There's a huge amount of money involved. This is a huge, big money scam.
There are not just now billions, but there are trillions of dollars at stake.
It's a story of self-interest and big government funding.
People like me, our careers depend on funding of climate research. This is what I've been doing just about my whole career. This is what the other climate researchers are doing with their whole career. They don't want this to end.
If CO2 isn't having the huge negative impacts that we claimed it was having originally, how are we going to stay in business?
A lot of people's livelihoods depend on it. They're not going to give that up.
This is a story of the corruption of science.
There's no such thing as a climate emergency happening on this planet now. There's no evidence of one.
The climate alarm is nonsense, you know, it's a hoax. I've never liked hoax. I think scam is a better word, but I'm willing to live with hoax.
It's a story about the bullying and intimidation of anyone who dares to challenge the climate alarm.
To speak up against or about climate change in any sort of skeptical way was essentially career suicide.
Activists are even calling for any skepticism to be criminalized.
It's the story of an assault on individual freedom.
It's a wonderful way to increase government power. If there's an existential threat out there that's worldwide, well, you need a powerful worldwide government, you know, to cope with it.
We see all these kind of authoritarian measures being adopted in the name of saving the planet.
You've suddenly got the population under control all over the world.
We called it industrial progress. Since the Industrial Revolution, the development of free market capitalist mass production has made ever more goods ever more affordable to ever larger numbers of people. Mass production marched hand in hand with mass consumption. In the modern age, ordinary people enjoy a level of prosperity never before achieved in human history. But all the while, we're told we were destroying the planet. Computers have calculated what is in store for us as we produce and consume ever more. The weather will get worse. The planet will boil. We greedy humans must accept limits on our lifestyle. Consume less, travel less. Those who deny the climate crisis are not just wrong, they're dangerous, spreading the poison of doubt among a gullible population. These deniers should be shunned and shamed and censored. For these climate deniers are flat earthers. They are anti-science. Teaching at New York University is one of these climate deniers. Professor Stephen Koonin is one of America's leading physicists. He was a science advisor to President Obama and both vice president and provost of Caltech, one of the most prestigious scientific institutes in the world.
I teach climate science to my students at NYU, and I always tell them, check the data or the papers yourself. And they all come out of that course with their eyes wide open.
Professor Koonin's best-selling book, Unsettled, argues that mainstream scientific studies, accepted by official agencies, do not support the notion that there is any kind of climate crisis at all.
Of course, I've been called a denier. And my response is, tell me what I'm denying, because I'm quoting from you directly from the official UN scientific reports.
Dick Lindzen also dismisses the claims of climate alarmists. He's one of the world's leading meteorologists, was professor of meteorology at both Harvard University and MIT, and has served on the UN's Intergovernmental Panel on Climate Change, or IPCC.
Even the Intergovernmental Panel on Climate Change, if you go to their section of Working One, Group 1, which is the science, they don't support any of these claims. And I assure you, having served on it, it's biased, but you couldn't get any real scientists to agree some of the nonsense that's being promoted.
Will Happer is also a denier and is another of America's leading physicists. He has been science advisor to 3 presidents and professor of physics at both Columbia and Princeton University.
There's this mischievous idea that's promoted that scientific truth is determined by consensus. In real science, you know, there are always arguments. No science is ever settled. You know, it just is absurd when people say the science of climate is settled. It's not. There's no such thing as settled science, especially climate.
Dr. John Clauser is one of the most respected scientists in the world. In 2022, he was awarded the Nobel Prize for Physics.
The science that's being done is appallingly bad, in my opinion. There are a large number of scientists who are in violent disagreement. They refer to themselves as skeptics. Since I am no longer worried about losing funding or a job, whatever, I call myself a climate change denier.
These very eminent and respected scientists, and others like them, are not flat earthers. They do not deny science. So what's the evidence that has caused them to dismiss the climate alarm as nonsense? We are told that current temperatures are unprecedented and dangerously high. It's possible to check if this is true because we have evidence of Earth's climate history dating back hundreds, thousands, even millions of years. The desert of Judea by the Dead Sea. Professor Nir Shavi from the Raqqa Institute of Physics has come here looking for clues. Thousands of years ago, this place was underwater, and etched into the rocks are lines which, if you know how to read them, tell the story of Earth's climate history.
And here's the climate. We're at the lake bed of what used to be Lake Lisan. It's a lake that existed until the end of the last ice age. Back then, the lake level was maybe 100 meters above where we're located. When we want to reconstruct climates of the past, we have to look for evidence, for clues. And when the lake existed, it had deposits. And by looking at these layers here, we can actually reconstruct how the climate has changed.
Warmer water means more life, the accumulation of more shells and bones from sea creatures, and other changes that are reflected in the ancient layers of the lake bed. The lines act as a kind of thermometer, and this is just one way geologists can reconstruct past climate.
In other places, we can go to stalagmite caves and see the annual rings that you have in the stalagmites, or we can drill cores from the bottom of the ocean and then look at layers there, or many other places. But here, I think this is one of the nicest places because you can actually see how the climate has changed.
So when we look back in time, what do we find? For 200 million years, dinosaurs roamed the Earth. An Earth marked by fertile, dense forests, teeming with life. And at no time during those 200 million years were temperatures as cold as they are today.
If you go back, let's say, 200 million years, it was maybe 13 degrees warmer than it is now. So, on the geological perspective, this is not at all unprecedented.
For the last 500 million years, temperatures have varied greatly. But for almost all that time, the Earth was much, much warmer than today. Compared to the last 500 million years, the Earth right now is exceptionally cold. In fact, there are very few times when it's been this cold.
We're relatively cold. Maybe not quite the coldest it's been in 500 million years, but pretty close to it.
We are in a remarkably cool period if we look over the last 550 million years. In fact, only one other time period in that last 550 million years was the temperature as cool as it is now.
The mammals who now inhabit the Earth began to evolve around 60 million years ago, when the world was much warmer than today.
If we just look at the last 65 million years, so this is after the dinosaurs go extinct, mammals really start to take over, and our evolutionary ancestors start to live on the land. Any time period within the last 65 million years was warmer than it is essentially today.
The Earth's mammals, humans included, appear to thrive when it's warm, warmer than it is now.
There's no doubt that warm is better than cold in geological history. We are a tropical species. A human being in the shade, naked, dies at 20 C from hypothermia. We evolved on the equator in Africa, and the only reason we were able to get out of there eventually was fire, shelter, and clothing.
Over the last 50 million years, temperatures steadily declined, plunging the Earth into what geologists call the late Cenozoic Ice Age. We are still in that ice age.
The reason there's all that ice on the poles is because we're in an ice age. Everybody knows that who knows anything about the history of the Earth. This is an ice age. We're at the tail end of a 50 million year cooling period, and they're saying it's too hot.
If we zoom in on the past few million years, we see temperatures sinking, and as they do, fluctuating between extremely cold periods and slightly milder periods. The extremely cold periods are called glacial maxima, when the planet is mostly covered in ice, and the slightly less cold are called glacial minima, when there's just ice at the poles. For the past 10,000 years, fortunately, we've been in a slightly less cold glacial minimum, known as the Holocene. With milder weather, humans began to emerge from their caves, and several thousand years ago, we see the rise of the first great civilizations, in a blissful period which, according to many studies, was considerably warmer than today. This is known as the Holocene climate optimum.
It was called an optimum because people thought that warmer was better.
Since then, temperatures have declined and begun to fluctuate. In Roman times, there was a blissfully warm period, followed by a brutal cold period in the Dark Ages. Then came the balmy medieval warm period, according to many studies as warm or warmer than today, followed by an especially cold period known as the Little Ice Age, possibly the coldest in the last 10,000 years. And here it is, the Roman warm period, the cold Dark Age, the medieval warm period, and then the very cold Little Ice Age, from which, for the past 300 years or so, we've been recovering. The longest instrumental record of temperature in the world comes from central England, and this is what it shows. Since the worst of the Little Ice Age, from 1650, the temperature has risen, gently, by little more than 1 degree Celsius.
The central England record of temperature is a world treasure. You know, it's the longest continuous record that we have, and it's certainly not a very alarming record. It began in the depths of the Little Ice Age, and so you can see the slight warming that followed the Little Ice Age. And there's certainly nothing very alarming that's happening today at the very end of the record. Most of the warming that we're observing today is the recovery from the Little Ice Age, whatever caused that.
Well, you know, we're talking over the entire industrial period of about 1 degree centigrade.
To put this 1 degree in perspective, let's look at New York Central Park. Records show that there has been no overall change in temperature here since 1940. But from one year to the next, the average temperature can vary by 3 degrees Celsius, without many New Yorkers even noticing. In fact, between the warmest year in the 1960s and the coolest in 2000, there's a difference of 5 degrees Celsius.
The average temperature on this day in this year might be 5 degrees different from the average temperature a year ago or 2 years.
You know, when I hear people pontificating about 1.5 degrees leading to the end of civilization, I think, what have they been smoking? You know, are you crazy? Right? So.
According to thermometer readings since 1880, there's been a very mild increase in temperature. Only by stretching the y-axis on this graph is the increase noticeable. This is the rising line used by official agencies as proof of global warming. But is it accurate? Professor Ross McKittrick is an expert in statistical analysis at Guelph University. He noticed something odd about modern thermometer records. Thermometers, even in the same region, give out very different readings, depending on where they're located.
I was interested in the question of how do you explain the spatial pattern of warming? So some places warm a lot, some places don't warm much. And it turns out it's highly correlated with the spatial pattern of economic activity.
Where there are more people and there is more human activity, there's more heat. This is known as the urban heat island effect.
Urban heat island effect is essentially London, right? You pick London. With buildings, with a lot of activities, tends to be a few degrees. I mean, we're talking now Celsius, right? Even 4 or 5 degrees Celsius warmer than outskirts. This is a phenomenon of urbanization. These days, the obvious effect is actually concrete retaining heat.
This can be illustrated with a satellite heat map of Paris. The center of Paris can be as much as 5 degrees Celsius warmer than the surrounding countryside.
Paris, London, Beijing, Shanghai, you name it, New Delhi, all of them absolutely demonstrated the effects.
So how has this affected the official temperature record? In the early part of the 20th century, it was normal to erect weather thermometers just outside towns, close enough to check every day, but away from the heat of urban life. But over the 20th century, those towns have expanded. Suburbs have spread. There are more roads, more cars. Thermometers which were once outside towns are now surrounded by shopping malls, offices, factories, and houses.
These towns and all the locations where thermometers are located, on average, they've all grown in population, let's say since 1880. You've got buildings growing up around the thermometers, you've got parking lots, so you've got all of these non-climate influences which are affecting the temperatures, which raises questions about the quality of thermometer data for monitoring global warming.
To correct for this corruption of the data, an obvious solution is to use only records from rural weather stations, which have been less affected by urban development. This has now been done by a team led by Dr. Willie Soon.
We combine all the best rural stations, anything that we can correct for, we correct for, and we show if you just don't use this data set and use only rural, you get a very different kind of picture.
According to rural temperature records, temperatures rose from the 1880s but peaked in the 1940s. Then there was a marked cooling until the 1970s. After that, temperatures recover, but are still today barely higher than they were in the 1940s.
What we see is that basically you have a warming from the 1850s or so to 1930s and 40s and started to warm and then cool in a substantial way to the 70s, about 76 or so. Instead of a long-term systematic warming trend, it has a variability, multi-decadal, like every 50, 60 years or so, kind of a variation.
It's not just rural thermometers that show little warming. Merchant ships and other naval vessels have been measuring the temperature of the sea since the 19th century. In red, we see the land temperature record since the 1860s, which has been inflated by urban thermometers. But in blue is the ocean temperature record. From around 1900, the two begin to diverge. Ocean records show far less warming in the 20th century, and the pattern more closely resembles the rural temperature record.
Sea is not supposed to be, quote-unquote, contaminated by urban heat island effect. Am I right? Yes? So when we compare the two records, within the range of uncertainty, this behavior actually fits.
Scientists have also studied temperature change by looking at tree rings, which again shows very little warming. There's a gentle rise till the mid-20th century, a cooling to the 1970s, followed by a mild recovery. Once again, it shows temperatures today are barely different to those of the 1930s and 40s, and the pattern closely resembles rural temperatures. Satellites, too, seem to be telling a different story. Our ability to measure global temperature accurately took a leap forward when satellites began to orbit the Earth. One of the scientists who pioneered the use of satellites to measure temperature is Dr. Roy Spencer, who in the 1980s was senior scientist for climate at NASA's Marshall Space Flight Center.
We were discussing over lunch, isn't there some way we can use satellites to monitor global temperatures? Because, as you know, the temperature network of thermometers is pretty skimpy around the world, so it's kind of hard to get a global temperature.
Dr. Spencer's development of weather satellites was revolutionary. He and his colleague, Professor John Christie, have been awarded NASA's Medal for Exceptional Scientific Achievement.
Our satellite data begins in January of 1979. That's when we have complete global coverage, and we have it right up to the present.
There was one critical question about temperature that satellites were singularly well equipped to answer.
Has there been a spurious warming that has crept into the global temperature record over land that's just a result of an increase in population? And that's something that we've been analyzing and working a lot on lately, and we're finding that, especially in urban areas, it's large. I mean, since 1880, most of the warming, it looks like, is due to the urban heat island effect.
We're lucky to have a few independent scientists like John Christie and Roy Spencer with their satellite measurements of temperature. You know, before they started releasing this, ground-based temperature records were going wild. They were going up, you know, like crazy with no bounds. But now they have to contend with the fact that there's this independent and probably better way of measuring the whole globe's temperature, which is not alarming at all.
Evidence from multiple sources now agree that the official global temperature record, as used by world governments and reported in the world's media, is showing far too much warming over the last 120 years, artificially inflated by urbanization.
You look at the weather balloon record, the satellite record, the rural record, the ocean record doesn't warm nearly as much as land. All of these indications show that the big warming pulse in the record is the Northern Hemisphere land record. And that's also where most of this data contamination is happening.
But of the mild warming that has taken place in the last 300 to 400 years, can any of it be attributed to human emissions of CO2? Professor Henrik Svensmark is visiting the Hebrew University of Jerusalem and taking a stroll in the Evolution Garden, dedicated to preserving the oldest surviving plant species on Earth. These plants aren't just pleasing on the eye. They can also tell us about levels of CO2 in the atmosphere in Earth's geological past.
What we have here is a ginkgo tree, and it's actually a living fossil in the sense that this type of tree first appeared about 270 million years ago. On the underside of the leaf, there are what we call stomata, the cells where they can uptake CO2. So they're actually measuring how much CO2 is in the air, and then they adjust the number of these stomata to how much CO2 there is. And by looking at fossils and measuring how many there are at a different time, it says something about what was the level of CO2 back in time.
So when we look back in time, what do we find? Over almost all of the last 500 million years, the level of CO2 in the atmosphere has been far, far higher than it is now. Even with modern industry's contribution to CO2 levels, by geological standards, the level of atmospheric CO2 today is close to being as low as it has ever been.
At present, we have about 400 parts per million. 50 million years ago, it might have been 2,000 parts per million. So a much, much higher concentration of CO2.
I think current estimates of global CO2 is 423 or so parts per million today. If we look through the Phanerozoic, the last 550 million years, we would see CO2 on the order of 7,000 parts per million.
CO2 is plant food, and the result of much higher levels of atmospheric CO2 in the past was a much, much greener world.
Periods of elevated CO2 tend to be time periods of a huge biodiversity on the planet. In fact, we're in a CO2 famine if we look over the last 550 million years.
At the depths of the most recent glacial maximum, the amount of CO2 in the atmosphere sank so low, all life on Earth came close to extinction.
They say CO2 is higher than it's been for 100,000 years, but what they don't tell you in that period they're talking about is that CO2 sank so low that all life on Earth nearly died.
20,000 years ago, CO2 is at the lowest level it has ever been in the history of the Earth, 180 parts per million. If it had gone down another 30 parts per million, we'd all be dead.
There is a low point of CO2 where photosynthesis becomes so inefficient that plant life would die. Then everything else starts to perish after that.
During the last glacial maximum, there's good evidence that in many parts of the world there was plant starvation from not enough CO2. So we should be very grateful that CO2 levels are beginning to go back up. We're still far from the historical norms, which would be several thousand parts per million. There's not enough fossil fuel to get there, but at least we're making a start.
But has the small recent increase in CO2 affected the temperature? We would now show you a picture of CO2, but we can't because it's invisible. CO2 makes up a tiny fraction of the gases in the atmosphere, just 0.04%. It is just one of 25 different greenhouse gases, which, taken as a whole, form only one part of Earth's complex climate system. So what evidence is there that this trace gas is having any noticeable impact on the climate? If it were true that higher levels of CO2 caused higher temperatures, we should be able to see that in Earth's climate history. Here, scientists are drilling into ancient ice cores. These cores tell us both about past temperatures and CO2 levels. Scientists have indeed found a link between temperature and CO2. The trouble is, it's the wrong way round.
So it's true over the last few million years of the ice age that we're in now that CO2 and temperature are correlated, but if CO2 is the driver, it has to change first, and the temperature has to change second.
In fact, when you start to look at the data very specifically, you see the exact reverse. Temperature starts to rise first, and then on the order of a century to a few centuries later, we start to see a rise in CO2.
It's long been known that the temperature actually moves first. So temperature goes up, CO2 goes up after that. Temperature goes down, CO2 goes down.
Ice ages start when carbon dioxide is at its maximum, and ice ages end when carbon dioxide is at its minimum, which is the exact opposite of what would occur if carbon dioxide was controlling the temperature.
The question of whether CO2 drives the climate is easily resolved. You can look back in time over hundreds of millions of years. CO2 levels have changed radically many times. Did this cause temperature change? No, absolutely not. CO2 has never driven temperature changes in the past, never.
Nor is it clear in recent times that CO2 is having any effect on temperature. Here we see industrial output of CO2 since 1750. From the mid-19th century to the mid-20th century, there was only a slight increase. It's not until the 1940s that industrial production of CO2 begins to take off. But this doesn't match the temperature record. According to rural thermometers, most of the warming in the past 200 years occurred before the 1940s, and have barely changed since then.
One of the embarrassments that IPCC doesn't like to talk about was that the 1930s, when human influences were much smaller, were particularly warm.
That's the puzzle, that the first early part where we have such a sharp warming from the 1900s to 1930s and 1940s, CO2 could never cause the temperature rise.
But the 1930s and early 40s were so hot is puzzling. More puzzling still is what happened next.
By the end of World War II, CO2 was really going up, and yet the temperature was going down.
From 40 to 70, while the CO2 continued to rise, this thing started to cool. What happened?
Journalists were writing about the coming ice age. It was on the cover of Time magazine.
1970s, the new ice age was the big story.
And how about since the 1970s? According to computer climate models, over the past half-century, rising CO2 should have led to this increase in temperature. But according to multiple satellite and balloon measurements, what actually happened was this.
Well, what we found from the satellite data is that the global atmosphere is not warming up as fast as the climate models say it should be. There's a couple dozen climate models now that have been worked on for decades. You know, billions of dollars, tens of billions of dollars have been invested in these climate modeling efforts. And we find that generally speaking, virtually all of the climate models produce too much warming over this period since 1979 up to the present. Now, even if we say the surface thermometers are correct, they still don't produce as much warming as most of the climate models say there should have been, let's say, in the last 50 years.
The models, individually and even collectively, when you average over all of them in so-called ensembles, they don't get it right.
You can already see that the main supports of the climate alarm movement, which are these enormous computer models, they're clearly wrong. They don't agree with what we observe. You know, they're all running much too hot. They don't get the geographical distribution of temperatures anywhere close. They don't get El Nino, La Nina cycles. They're just nonsense.
All climate models are based on the assumption that CO2 drives temperature change. But actual observations and historical evidence clearly suggest that it doesn't.
Yes, I assert that there is no connection whatsoever between CO2 and climate change. That's all a crock of crap, in my opinion.
There is no truth to the idea that the Earth is warmer now than it has been in the past. It's a lie. There is no truth that CO2 is higher than it should be. That is a lie.
Earth's climate has changed many times over the course of its long history and will continue to change without any help from us.
Climate always changes, you know. Who denies climate change? It's always changing.
But if CO2 doesn't drive climate change, what does?